All right, class, here's another combined gas law problem. This time we're finding the temperature after a balloon goes through some changes. So here we can see a balloon starts at sea level on a cool spring day. There's a volume of 16 liters, so that's our first volume. Sea level, that's going to tell us the pressure. Yeah, that pressure is 1 atmosphere at sea level. That's pressure 1. Temperature is 15 degrees Celsius, so it's a relatively cool day. That's temperature 1. The balloon rises into the clear blue sky, so that would indicate a higher pressure than just standard, and it expands to a volume of 19.2 liters with a pressure of 0.769 atmospheres. What's the temperature in the balloon after this has happened? Well, the combined gas law says that P1 times V1 divided by T1 is a constant value, so that will equal any other pressure, volume, and temperature at a later place in time. Now, I've identified volume 1 is 16, pressure 1 is 1 atmosphere, temperature 1 is 15 degrees Celsius. Now this is volume 2, this is the volume later on, and this is that pressure then, and we want to find what's the temperature. We want to find it in Celsius. Now, the pressure units have to be the same, so atmospheres and atmospheres. The volume units have to be the same, liters and liters. The temperature units have to be Kelvin. So we got to change this T1. It's 15 degrees Celsius, but we got to add 273 to make that Kelvin. So that's 288 Kelvin is temperature 1. Now what I want to find here is temperature 2. So temperature 2 is on the bottom over on this right side, but it needs to be up on top. So I'm going to cross multiply that over to here, and so I'll get the T2 over here. So we've been through some of the algebra, and what happens is when we have these two fractions, we can cross multiply. So this, anything that's on the bottom on the right can go to the top on the left, and likewise we can do the reverse. Bottom on the left can go top on the right, and I'll show you what that looks like here. I gotta let my dog in. Okay, so that T2 comes over here, up on top. This P1 and V1, they've got to go down to the bottom. This T1's going to go up on the top. So that leaves P2, V2 up there. The T1 comes up here, T1. The P1 and V1 come down over here, P1, V1. Now that follows all the basic laws of algebra, right, to do that. If you need to see that in more detail, send me a message, maybe I'll make a video, or look at the previous video where I rearrange things. So now I just got to plug all those numbers in. Pressure 2, 0.769 atmospheres. Volume 2, 19.2 liters. Temperature 1, 288 Kelvin. I didn't need to put the K there, but I did. Divided by pressure 1 times volume 1. Pressure 1 is 1 atmosphere. Volume 1 is 16 liters. That's a times. I'm going to put that in brackets because those have to be multiplied together first before they're divided. Now I just plug it into my calculator correctly. All right. So 0.769 times 19.2 times 288 divided by the quantity in parentheses 1 times 16. Boom. Remember, I have to divide by the product of those two. Both of them are on the bottom. Hit enter. Boink. That is the temperature in Kelvin. So we've got T2 equals 265.77 Kelvin, but I need it in Celsius. So subtract. We take Celsius, we add 273 to make it Kelvin. So to take Kelvin, become Celsius, subtract 273. When I do that, up here on my little calculator, minus 273, enter, I get negative 7.2, right, to 1 decimal place. So temperature 2, negative 7.2 degrees Celsius. Okay, entering in your calculator properly is important. Correctly rearranging following the laws of algebra is very important too. That's the two places people make mistakes. They don't rearrange things correctly for the unknown, and then they don't plug them in a calculator right. Got to be smart in your calculator.